This is the EdExcel GCSE 91 Maths paper 3, which is a calculator paper, and it's from the higher tier from the Specimen Set 2 papers. Question 1. The ratio of the number of boys to the number of girls in a school is 45. There are 95 girls in the school. We have to work out the total number of students in the school. So what we know already, the ratio of boys to girls is given by 4 to 5. And we know already there's 95 girls in the school. And we have to work out the total number of students in the school. Well, before we do anything else, we need to work out the number of boys. Now, to go from 5 to 95, we multiply by 19. And therefore, 4 times by 19, that's 76. So there's 76 boys in the class. So the total number of students is 76 plus 95, which is 171. So we have 171 students in the school. Question 2. The diagram represents a solid made from 7 centimeter cubes, and that's what we see here. And on the grid here, we have to draw a plan for the solid. Well, what do we mean by the plan? Well, the plan means we are looking down on the shape. So when we look at the top view, we see what's shaded here. So we need to draw this onto our grid. So we have something looking like this for our plan. Question 3, we have to make t the subject of the formula y equals t over 3 minus 2a. Well, first thing we can do is add 2a to both sides. So we have y equals y plus 2a equaling t over 3. Now we want to get t by itself. Now you can see here t has been divided by 3, so to undo this 3 here, we need to multiply by 3 on both sides. So we will now multiply by 3 on both sides. And if we do that, you can see here, we end up with t equals 3 lots of y plus 2a. So we have t equals 3 lots of y plus 2a. Question number 4. Jim rounds a number x to 1 decimal place. The result is 7.2. We have to write down the error interval for x. Well, the error interval, we need to work out the upper and lower bounds before we do anything else. The upper bound of x is equal to 7.25, and the lower bound of x, this is equal to 7.15. So therefore, the error interval, that's given by the lower bound, which is less than or equal to x, which is less than the upper bound. So here we have 7.15, which is less than or equal to x, which is less than 7.25. Question number 5. Katie measured the length and the width of each of 10 pine cones from the same tree. She used her results to draw this scatter graph, and that's what we see here. So we've got the length and the width both in centimeters, and for part A we have to describe one improvement Kate can make to her scatter graph. Well, here you can see there's no pieces of data that's been used here. So what we can do instead is start our graph over here somewhere. So we can start our graph over here. And of course, in doing so, we'll have missing axis. So let's just show that here. So we can start our graph off at, say, this point over here. So let's just write down that improvement. So we can start the graph off at 4, 3 instead of 0, 0. Now for part B, the point representing the results for one of the pine cones is an outlier. We have to explain how the results for this pine cone differ from the results for the other pine cones. So if we take a look here, let's just circle it. Here we have an outlier. Okay, so here we've got the outlier. So when we come to describe how this result differs from the other results we see here, let's just write down some appropriate explanation for this outlier. Well, for this length over here, which is around 6 centimeters, the width is extremely low. Now if we compare that with, say, this point, you can see the length here is quite high for a similar length. So therefore, its width is small for its length. Question 6. At a depth of x meters, the temperature of the water in an ocean is T degrees C. At depths below 900 meters, T is inversely proportional to x. T is given by T equals 4,500 over x. For part A, we have to work out the difference in the temperature of the water at a depth of 1200 meters and the temperature of the water at a depth of 2,500 meters. Well, here, when x is equal to 1200, of course, this would correspond to 1200 meters. T is equal to 4,500 over 1200. So let's work out this value. We have 4,500 over 1200, which is 3.75. So we have 3.75 degrees C. And when x is equal to 2500, T is equal to 4,500 divided by 2500. So if we work this out, 4,500 divided by 2500, that's 1.8 degrees C. And therefore, the difference is what we need to work out. So we have 3.75 take away 1.8, which is 1.95. So we have 1.95 degrees C. Now here are 4 graphs, A, B, C, D. One of the graphs could show that T is inversely proportional to x. We have to write down the letter of this graph. Well, of course, for a graph that's inversely proportional to x, we have, in this case, T equaling some constant over x. So here, we've got T being inversely proportional to x. So in other words, we've got T equaling some constant k over x. Now the k is just stretching the graph, so we don't need to worry about that for now. So you can see the graph of k over x, well, that's going to be d. Question 7, here is a right-angled triangle, so we've got a length of x here and a length of y here. 4 of these triangles are joined to enclose the square ABCD as shown below. We have to show that the area of the square is x squared plus y squared. Okay, so we're looking for the area of the square ABCD. Now, what we can do here to find out that area, well, we can find out the area of the larger square, then subtract off these triangles here, and that will help us find the area of the shorter unshaded square. So, if we have a length of x here, so every little length here is x, and we have a length of y here, then the area of a triangle, let's just write this down, that will equal 1/2 times by the base, which is, well, it can be x or y, so let's just write x here, multiplied by the height y. Now we've got 4 of those triangles, so therefore the area of 4 triangles, we're going to have 4 lots of 1/2 xy, which is equal to 2xy. Okay, now let's work out the area of the larger square. So the area of the larger square, well, here we've got dimensions x, y. Rather, here we've got dimensions x plus y for one length of the square, so we've got x plus y, and then we will square this because we've got the area of a square. So here we've got x squared plus 2xy plus y squared, and therefore the area of the square ABCD is equal to x squared plus 2xy plus y squared minus the 2xy from here. So it turns out here we get x squared plus y squared. Question number 8. The diagram shows an oil tank in the shape of a prism. The cross-section of the prism is a trapezium. That's what we see here. We have a trapezium. The tank is empty. Oil flows into the tank. After 1 minute, there are 300 litres of oil in the tank. Assume that oil continues to flow into the tank at this rate. We have to work out how many more minutes it takes for the tank to be 85% full of oil, and we're given that 1 meter cubed is equal to 1,000 litres. Well, here the flow rate if oil goes into the, if after 1 minute there's 300 litres, that means that we have 300 litres per minute for the flow rate. Now, we can use this information, well, we'll ignore this for now. Let's work out the volume of the tank over here. Before we do anything else, we need to work out the area of the, well, the volume of the tank. We've got 1/2 multiplied by the sum of the two parallel sides, so we've got 1.4 plus 3, and then we multiply this by 2.4. So what we've got over here is the area of the trapezium. Okay? And then we're going to multiply this by 2.5, which is the width over here. So we can find out the volume. We've got 1/2 times by 1.4 plus 3 multiplied by 2.4 multiplied by 2.5, which is 13.2. So we've got 13.2 meters cubed for the volume of the tank. So this is the capacity. So therefore, if we know that 1 meters cubed is equal to 1,000 liters, if I multiply 13.2 by 1,000, we get 13200. So we have 13200 liters for the volume of the tank. Now, 85% of the volume, this is equal to 0.85 multiplied by 13200. So if I multiply this by 0.85, we get 11220 liters. And what we're doing in this question is questioning how long it will take to fill this amount of the tank, given that we fill 300 liters every minute. So therefore, to find out the time, this is equal to 11220 liters divided by 300 liters per minute. So if I divide this 11220 by 300, we get 37.4 minutes. Okay, so we've got 37.4 minutes. So this is the time taken to fill 11220 liters, and therefore, because 1 minute has already been spent filling 300 liters, we've got 37.4 take away 1, which is 36.4. So we've got 36.4 minutes, because we know already it takes 1 minute to fill 300 liters, and we're questioning how many more minutes it takes to fill the tank to this amount here. For part B, the assumption about the rate of flow of the oil could be wrong. We have to explain how this could affect your answer to part A. So if the flow rate was lower than 300 liters per minute, then it would take longer to fill the tank. And that's because it takes longer to fill a certain amount. Question number 9. Ibra bought a house for £145,000. The value of the house depreciated by 4% in the first year. The value of the house depreciated by 2.5% in the second year. Ibra says 4 plus 2.5 is 6.5. So in 2 years, the value of my house depreciated by 6.5%. Is Ibra right? You must give a reason for your answer. Well, here, the total depreciation is equal to, well, if it's depreciated by 4% in the first year, then here we've got 0.96. And if it's depreciated by 2.5 in the second year, here we've got 0.975. So therefore, if we multiply these together, 0.96 times 0.975, this is 0.936. So we've got 0.936. And therefore, the reduction is equal to 1 minus 0.936. So 1 minus this is 0.064, which is equal to 6.4%. So therefore, he is wrong. Now for part B, the value of Ibra's house increases by X% in the third year. At the end of the third year, the value of Ibra's house is 140,000. We have to work out the value of X. So let's think about how we can go about this question. Well, we've got the original price of the house, which is 145,000. We're going to multiply this by 0.96, which corresponds to the amount in the first year. Then we're going to multiply by 0.975, so this is the rate in the second year. And then in the third year, it increases by X%. So we're going to multiply by 1 plus X over 100. So this is the amount in the third year. And the end result is 140,000. Okay? So we need to work out what, so here first of all is the amount in the third year. So we need to work out what X is. So 145,000 multiplied by 0.96 multiplied by 0.975. This is 135,720. So I've got here 135, I'll just write it in black, 135,720 multiplied by 1 plus X over 100. This is equal to the amount that's left over, 140,000. So if I divide 140,000 by this amount, we get 1.0135. So I've got 1 plus X over 100, which is equal to 1.0315. And if I rearrange for X, well, if I subtract 1 and then multiply by 100, you can see X is equal to 3.15 to 3 significant figures. So X is equal to 3.15 to 3 significant figures. Question number 10. The surface gravity of a planet can be worked out using the formula G equals 6.67 times 10 to the minus 11 multiplied by m over r squared, where m is the mass of the planet and r is the radius of the planet. M is in kilograms, r is in meters. For the Earth and Jupiter, here are the values of m and r. So for Earth, we see that m is equal to 5.98 times 10 to the 24. R is equal to 6.378 times 10 to the 6. And for Jupiter, m is equal to 1.90 times 10 to the 27. And r is equal to 7.149 times 10 to the 7. We have to work out the ratio of the surface gravity of Earth to the surface gravity of Jupiter. Write your answer in the form 1 to n. So let's think about how we can do this. Well, obviously we need to actually work out what G is for Earth and for Jupiter. So for Earth, if we work out what G is, let's just grab a ruler. Let's just draw a straight line here. So G is equal to, well, we've got 6.67 times by 10 to the power of minus 11 multiplied by m, which you can see here is 5.98 times by 10 to the power of 24 divided by r squared. So r is 6.378, and then we're going to multiply by 10 to the power of 6 squared. So let's work out what G is. So let's just rub this bit out here. if I work out, so let's just move this here. So let's type in the fraction button and then open up the bracket. Well, we've got 6.67, and then if I press this button and then minus 11, this is what's shown here, close bracket. Then we've got the 5.98 times 10 to the 24, close bracket, and on the bottom we've got something squared, and that something is 6.378 times 10 to the 6. So if we work this out, it turns out we get 9.805234578. So this is the value of G for Earth, and now we need to work out the value of G for Jupiter. So for Jupiter, G is equal to, let's just grab this line again. We've got 6.67 times 10 to the minus 11 multiplied by 1.90 times 10 to the 27 over 7.149 times 10 to the 7 squared. So let's work this out. So here, what's inside this bracket we will change to a 7.149 times 10 to the 7, and what's in this bracket we will change to 1.90 times 10 to the 27. So it turns out here we get 24.796411183. Okay, so this is the value of G for Jupiter. And now the ratio of the surface gravity of Earth to Jupiter, this is equal to 9.805, etc., to 24.79, etc. So if we write this in the form 1 to n, well, you can see here we'd have to divide by 9.805, etc. And here we'd have to do the same thing. So we will divide 24.79, etc. by 9.805, etc. So if I do that, I'm going to divide this by 9.805 234578. So it turns out here we get a value of 2.516802839. So therefore we've got 1 to 2.52 to 3 significant figures. Question number 11, we have to solve the simultaneous equations 2x minus 4y equals 19 and 3x plus 5y equals 1. To do this question, what we can do is get the y's the same, for example. We could, if we want, get the x's the same, but I'm going to choose to get the y's the same. So let's call this equation 1, and let's call this second one equation 2. Now, to get the y's the same, we will multiply equation 1 by the coefficient of y from equation 2. So we will multiply equation 1 by 5. And we will multiply equation 2 by 4, which is the coefficient of y in equation 1, ignoring any signs. So we will multiply the second equation by 4. And if we do that, we end up with 2x. Well, here we've got 5 lots of 2x, which is 10x. So we've got 10x minus 20y equals 95. And then here, if I multiply equation 2 by 4, we get 12x plus 20y equals 4. I'll call this equation 3, and I'll call this bottom one equation 4. You can see that the y's are the same. We've got 20y, the signs are different. So here we need to add these equations together. So if I just move this slightly here, we now need to add together equation 3 and equation 4. And if I do that, 10x plus 12x, you'd find that to be 22x, minus 20y plus 20y, that's just 0y, 95 plus 4, that's 99. So 22x is 99, and therefore x is equal to 99 over 22, which is 4.5. Now when x is equal to 4.5, we can substitute this into any of these equations to find the corresponding value of y. For example, let's substitute into equation 2. We've got 3 lots of 4.5 plus 5y equals 1. So 3 times 4.5, that's 13.5. So I've got 13.5 plus 5y equals 1. Subtracting 13.5 from both sides, we get minus 12.5. So 5y is equal to minus 12.5, and if I divide through by 5, we get minus 2.5. So therefore y is equal to minus 2.5. So we've got x equals 4.5 and y equals minus 2.5. Question 12. Zara mixes 150 grams of metal A and 150 grams of metal B to make 300 grams of an alloy. Metal A has a density of 19.3 grams per centimeters cubed. Metal B has a density of 8.9 grams per centimeters cubed. We have to work out the density of the alloy. Well, here we've got densities, we've got masses over here, and we need to work out the density of C. So what connects all those is the formula, density equals mass over volume. Okay? So for metal A, we can work out the volume because we've been given the mass and we've also been given the density. So the volume is equal to the mass, 150 grams, over the density, which is 19.3 grams per centimeters cubed. So if we work this out, 150 divided by 19.3, you'd find here we get 7.77, etc. So here we've got 7.77, etc. centimeters cubed. Let's store this into A. If we now take a look at metal B, the volume can be worked out using a similar method. We have 150 grams over 8.9 grams per centimeters cubed. So if we work this out, we have 150 divided by 8.9, which is 16.85, etc. centimeters cubed. Let's store this into B. Now to work out the density of the alloy, we need the total volume and we also need the total mass. So the total well, here the for the alloy, the total mass is equal to the 150 grams from metal A plus another 150 from metal B. It turns out here we get 300 grams, and the total volume is equal to 7.77 etc. centimeters cubed plus 16.85 etc. centimeters cubed. So if I work this out, here we've got A plus B, which is 24.62 etc. centimeters cubed. And therefore, for the density, that will equal the mass over the volume. So we've got the mass, which is 300 grams, over the volume, which is 24.62 etc. centimeters cubed. So if we work out the density, 300 divided by this is 12.18 etc. So we've got 12.18 etc. grams per centimeters cubed. Of course, to three significant figures, we've got 12.2 grams per centimeters cubed. So this is the density of the alloy. Question 13. On the grid, we have to enlarge the triangle by scale factor minus 1.5 with center 0.2. So first of all, let's show our center. Our center is over here somewhere. And when we come to enlarge a shape, what I like to do is show the lines that go through this point, through each of the points of the triangle. So what I mean by that is, for example, this point, if I draw a line through the point 0.2 as accurately as I can, we've got this over here, okay? And for example, this point, it goes through this point here, so we have something looking like this for let's think about this. We've got something looking like this, okay? So 4 across 2 up, so here we're going to go 4 across 2 up, yeah. And then for this point, goes through here, like so, okay? And you can see how it all goes through that point here. Now because we're going in the opposite direction, because here we've got a minus, well, we need to multiply this length by 1.5. So 4 multiplied by 1.5, that's going to be 6. So here we're going to go 6 this way. So we've got 1, 2, 3, 4, 5, 6. So here we've got one of the points. Then, well, from here to here we go 2 across 2 up. So 2 times by 1.5, that's going to be 3. So here we're going to go 3 this way and then 3 down. That's going to go here, and presumably here we've got 4 across 2 up, so here we're going to go 6 this way and 3 down to this point here. So here is the enlarged triangle as we see here, okay? Question 14. The table gives information about the speeds in kilometers per hour of 81 cars, and for part A we have to draw a histogram for the information in the table. So here, the formula for when we're dealing with histograms, well, let's just show that here. We have the frequency density multiplied by the class width, which is equal to the frequency. So before we do anything else, we need to work out the class width, so we can do that here. We also need to work out the frequency densities as well. So here the class width, you can see here is 10. Class width here is 5. Class width here is 5. Class width here is 10. And class width here is 20. Now, the frequency density we can find by dividing the frequency by the class width. So, 13 divided by 10, that's 1.3. 16 divided by 5, that's 3.2. 18 divided by 5, that's 3.6. 22 divided by 10, that's 2.2. 12 divided by 20, that's 0.6. So we've got the frequency densities, we've got the class widths, we've also got the frequencies. So when we come to, well, let's just first of all label the axis. So here we've got the frequency densities, we need to show that, and here we've got the speed. And don't forget the units of speed, we have kilometers per hour. So we're going from 90 to 140, so let's start off with here 90, 100, 110, 120, 130 and 140. Okay, and then here we've got 0, 1, 2, 3, 4 and 5. So we can now create a frequency a histogram. So here we've got between 90 and 100, we've got a frequency density of 1.3. So 1.3, that goes here. And between, well, let's just grab a vertical ruler here. Let's just switch this over to a vertical ruler, as we see here. Next we've got between 100 and 105. That's going to be 3.2. So 3.2 is here. Okay, so let's just roll off over here, and similarly over here. Next one, between 105 and 110, we've got 3.6. So 3.6, that is over here. So let's just rule this section off here. So we've got 3.6. And then between 10 and 120, we've got 2.2. So between 110 and 120, we've got 2.2, which is over here. So let's just roll down here. And next, between 120 and 40, we've got 0.6. So 0.6 is over here. So let's just rule across like so. And therefore, this is our completed frequency, this is our completed histogram. Now for part B, we have to find an estimate for the median. So part B, find an estimate for the median. Well, before we do anything else, we need to find out where the median lies. And for that, we need to work out the cumulative frequency. So we start off with the 13. 13 plus 16, that's 29. 29 plus 18, that's 47. 47 plus 22, that's 69. And 69 plus 12 is 81. Okay, so half of 81, so if I do 81 divided by 2, this is going to be 40.5. So we want the 40.5th value, and you can see that lies in this interval here between 105 and 110. So therefore the interval is 105, which is less than S, which is less than or equal to 110. So we need to find out the median. Okay, so let's think about how to do this. Well, one way we can do this is to use the gradient method, which is the method I always use. So we draw a straight line, and the median is going to lie somewhere in here, in between 105 and 110. So what we do is add in 105 from here, and if we go back to the diagram here, you can see there's 29 with a speed of 105 or less. Now here we've got the median Q2, and that corresponds to 40.5, and here we've got the 110, and if we go back here you can see we've got 47 with a speed of 110 or less. So now we can use the idea that if we just make this smaller, here we can use the gradient idea. So we've got the change in y's will always be the same, and so will the change in x's. So change in y here, we've got, well, one other way we can do it is Q2 minus 105 over 40.5 take away 29 is equal to 110 take away 105 over 47 take away 29. So what we need to do is find out what Q2 is, and therefore this is actually quite straightforward to do, because we can see here Q2 will equal this amount here. So if I just copy and paste this, we're going to have this amount here being multiplied by the difference. We've got 40.5 take away 29, and then we're going to add on 105. So let's just actually move this down here. So if I work this out, Q2 is going to equal, through linear interpolation, I've got here 110 take away 105 over 47 take 29, and this is multiplied by 40.5 take away 29, and then I'm going to add on 105. So therefore I'm going to end up with 108.19, etc. Okay, so I'm going to end up with 108.19, etc. kilometers per hour. So I've got 108.2 to 1 decimal place. Okay. Question 15, we have to show that a over b plus 1 minus a over b plus 1 all squared can be written as ab over b plus 1 all squared. So here, this will be equivalent to, now if I just grab a ruler and just make this ruler horizontal, like so, we can rewrite a over b plus 1 so it has a denominator of b plus 1 squared. I want the denominators to be the same. Now, for us to have a b plus 1 all squared at the bottom, I need to have a a lots of b plus 1 at the top. It's as though these cancel out, leaving us with a over b plus 1. And then I'm going to subtract off b plus 1 all squared, a over b plus 1 all squared. So now I need to simplify all of this. So this is equivalent to, I'll grab my ruler again, a lots of b plus 1 minus a over b plus 1 all squared. So now we can simplify all this. So we've got ab plus a minus a over b plus 1 all squared, which simplifies to ab over b plus 1 all squared. Okay, and that's exactly what we wanted to show. Question 16, the diagram shows a sector of a circle of radius 4 centimeters. So that's what we see here, and we have to work out the length of the arc ABC. So this arc over here, give your answer to the three figures. So first of all, we can find out this angle over here, recognizing the angles around a point sum to 360. Here we've got 360 minus 100, which is 260. So the arc length this is equal to 260 over 360 multiplied by pi r, 2 pi r. So we've got 2 times by pi times by 4. So this is what the arc length is. So we've got 260 over 360 multiplied by 2 pi multiplied by r, which is 18.15, etc. So indeed we get to three significant figures, 18.2 centimeters. Question 17. The product of two consecutive positive integers is added to the larger of the two integers. We have to prove that the result is always a square number. So here we've got consecutive integers. Well, we begin with integer n, then n plus 1, that's the next integer. Integer after that we've got n plus 2. Integer after this we've got n plus 3, and then we can continue on. Now what it's saying over here is we've got the product of two consecutive integers being added to the larger of the two. Well, if we choose these two integers n and n plus 1, the product of those, we've got n lots of n plus 1. So here we've got the product of two consecutive integers, as we see here, is being added to the larger of the two. The larger of the two is n plus 1. So what I've just done over here is added the larger of the two integers, which is n plus 1. And we want to show that this is a square number. So n lots of n plus 1, that's n squared plus n, and then I'm going to add on the n plus 1. So I've got n squared plus 2n plus 1, and you'd recognize this is the same as n plus 1 all squared. So this over here is a square number. Question number 18. Here is a speed time graph for a car. That's what we see here. We've got the speed in meters per second and then the time in seconds. For part A, we have to work out an estimate for the distance the car travelled in the first 10 seconds. Use 5 strips of equal width. So if we use 5 strips of equal width, well, here we're going to have 2. Here we've got 4. Then we've got 6 here. So we've got 1, 2, 3 so far. 4 strips. And then we've got the 5th strip, as we see here. So now we need to join all these up into, as we see here, So let's just join these up as we see here. And of course the area under a speed time graph corresponds to the distance. So here we've got a triangle. We've got 1/2 times by the base, which is 2, times by the height, which is well, here 5, every little 10 squares is 5, so every 2 little squares is going to be 1. So here we've got 2. Then here, for this portion, we've got a trapezium. So, well, the height here is going to remain as 2. And the sum of the two parallel sides, well, we've got 2 here, plus 5 here. And then next, we've got 5 plus 9, because again we've got a trapezium, and then we're going to multiply this by 2. Next, we've got half lots of 9, plus over here we've got 15 multiplied by 2, and then finally we've got a half lots of 15 plus, well, here we've got 24, and then we will multiply by 2. So if I work all of this out, we have a half times by 2 times by 2, which is 2. Well, here we're going to have actually 2, and then here we've got 2 plus 5, which is 7. 5 plus 9, that's 13. 9 plus 15, that's 24. And 15 plus 24, that's 39. So if I add all this together, we get 86. So we have 86 meters. And now for part B, is our answer to part A an underestimate or an overestimate of the actual distance? Give a reason for your answer. Well, if we take a look over here, the trapezia are above the curve, so we have an overestimate. Let's just write that down. So the trapezia are above the curve, and therefore we have an overestimate. Question 19, we have to prove algebraically that the recurring decimal 0.318 recurring, where the 1 and the 8 are repeating, can be written as 7/22. Well, here we will let x equal 0.3181818, etc. And because we've got 2 digits repeating, we're going to multiply this by 10. So here we've got 10x equals, well, if I multiply, well, because we've got 2 digits repeating, rather we're going to multiply by 100. So if I multiply this by 100, we end up with 31.8181818, etc. So now if we subtract these together, 100x take away x, that's 99x. Okay, so we've got 99x, which is equal to, well, here, these values, we think about which values cancel. Well, this cancels, this cancels, this cancels, this cancels, this cancels, this cancels, etc. So we've got 31.8 take away 0.3, which is 31.5. So therefore x will equal 31.5 over 99. So if we simplify this, we've got 315 over 990, which simplifies to, if I type this into my calculator, 315 divided by 990, which is 7/22. So here I've got 7/22. Question 20. OAB is a triangle, that's what we see here. Point P is such that, well, point P is on the line AB, such that the ratio AP to PB is 5:3. OA is equal to 2A, OB is equal to 2B, and OP is equal to K lots of 3A plus 5B, where K is a scalar quantity, and we have to find the value of K. So from this statement alone, we can conclude that AP, the vector AP is equal to 5/8 of AB. And if you want, you can also say PB is equal to 3/8 of AB. So it might be a good idea for us to work out AB. AB, starting at A, finishing at B, well, we need to go to O from A, so we've got AO. And then we need to add on OB. So here we're going to have minus 2A plus 2B. Now, OP is equal to K lots of 3A plus 5B. Well, how does this help us? Well, let's actually find out the vector OP. Well, for that we need to find out what AP is. So AP is equal to 5/8 lots of AB. So we've got 5/8 lots of minus 2A plus 2B. So here we've got, well, we're going to end up with minus 5/4 A plus 5/4 B. So now we can define OP to equal OA plus AP. So here we've got 2A plus minus 5/4A plus 5/4B. So if I work this out, you can see here 2A plus minus 5/4A, that's 3/4A. And then here we've got 5/4B. And if I take out the 1/4 as a common factor, we've got 1/4 lots of 3A plus 5B. So therefore you can see here K is equal to 1/4. So therefore K is equal to 1/4. Question 21. ABC is a triangle. D is the point on AB. We have to work out the area of the triangle BCD. That's this triangle here. Well, for us to work out the area of the triangle, what we need is an angle and two lengths. We need 2 lengths and an angle in between those 2 lengths. So ideally we need this length CD, and we also need the length CB. So let's think about how we can do this. Well, we can find out what CD is using the cosine rule. CD squared is equal to 4.9 squared plus 3.8 squared minus 2 lots of 4.9 times by 3.8 times by the cosine of 80. So if I work this out, we have 4.9 squared plus 3.8 squared minus 2 times 4.9 times 3.8 multiplied by the cosine of 80. So here we get 31.98 etc. So therefore CD is the square root of this, which is 5.65. So therefore CD is equal to 5.65, etc. So this length is 5.65, etc. centimeters. Let's store this into A. Now, we need to work out this length somehow. And let's think about how we can do this. Well, for us to do this, we can, well, if I know this angle here, then I can find out this angle here. And to find out this length, I can use the sine rule. So let's find out what the angle CDA is, and we can do that using the sine rule. So we've got the sine of CDA over 4.9. This is equal to the sine of 80 over the 5.65, etc. So therefore, we can work out the sine of CDA to equal sine of 80 over 5.65, etc. multiplied by 4.9. So let's work this out. So we've got the sine of 80 over this answer multiplied by 4.9, which is 0.150, etc. So therefore, the inverse sine of this is equal to 8. If we work this out again, we've got the 4.9 multiplied by the sine of 80 over this value of A. So sorry, here we get 0.853, etc. So therefore, the inverse sine of this is 58 degrees. So we've got 58.5, etc. So therefore, CDA is equal to 58.5, etc. So we have 58.5, etc. degrees. So let's store this into our calculator under B. So this answer, let's store into B. So therefore, this angle here is going to be 180, the angle CDB. So therefore, CDB, that's going to equal 180 minus the 58.5, etc. because we've got angles on a straight line. So 180 minus this is 121.4, etc. So let's store this into C. So we've got 121.4, etc. So this angle is 121.4, etc. That's this angle here. And we need to work out what CB is now. Well, let's think about how we can do this. Well, if I know what this angle is over here, we can use the sine rule again. So the angle CBD, we can easily work that out. CBD, that will equal 180 minus the 121.4, etc. minus the 25. So here, if I do 180 minus this minus 25, I get 33.5, etc. So I get 33.5, etc. for this angle here. So here we've got 33.5, etc. for this angle here. So let's just make it, yeah, that'll do. So now we need to work out what CB is, and we can do that using the sine rule. We have a length and an angle opposite it, and here we've got a length and an angle opposite it. So we've got CB over the angle opposite it, which is 121.4, etc. So here we've got CB over the sine of 121.4, etc. This is equal to the 5.65, etc. over the sine of 33.5, etc. So we need to find out what CB is. Finding CB is quite easy. CB is equal to this, so let's just copy paste this here, multiplied by the sine of 121.4, etc. So let's work this out. We have so this value, so we've got that value A over the sine of this multiplied by the sine of C, which is 8.72, etc. So we've got 8.72, etc. Let's add this to the diagram. 8.72, etc. centimeters. And now we can use the area of a triangle formula to work out the area of the triangle BCD. Therefore, the area of BCD, that will equal 1/2 multiplied by the 5.65, etc. multiplied by the 8.72, etc. multiplied by the sine of 25. So let's work this out. We've got this value multiplied by 0.5 multiplied by A multiplied by the sine of 25. So here I get 10.42, etc. centimeters squared. So we've got 10.4 centimeters squared to 3 significant figures. Question 22. There are white black socks and 6 and 5 white socks in a drawer. Joshua takes at random 2 socks from the drawer. The probability that Joshua takes 1 white sock and 1 black sock is 6/11. We have to show that 3y squared minus 28y plus 60 equals 0. Well, to do this question, I think it will be a good idea to draw a tree diagram. So here we've got the branches of our tree diagram. Now let's fill in the probabilities. So here, well, in total, if there's y black socks and 5 white socks, in total we have y plus 5. So we've got y plus 5 here and here. And of those y plus 5, y of them are black and 5 of them are white. So the probability of picking a black is y over y plus 5. Probability of a white is 5 over y plus 5. Now, if we take 1 sock out, that means the remaining number of socks will be 1 less than y plus 5, which is y plus 4. So we have over here y plus 4. We have here y plus 4, and we have here y plus 4. Now, if we take 1 black sock, we'll have 1 less black sock, so here we've got y minus 1, and the number of y socks remain the same. And if we take out 1 white sock, here we've got 4, and here we've got the black socks remaining the same as y. Now, the probability that it takes 1 white and 1 black is equal to 6/11. So the probability that he takes a white sock and a black sock is 6/11. So one way we can do that is taking a black, then a white, or we can take a white, then a black. And of course, this is equal to 6 over 11. So probability of black and white, well here, let's just show this over here. Of course, the probability that we pick a black first, that will be y over y plus 5, and then we will multiply this by 5 over y plus 4. Okay, so here we've got 5 lots of y plus 4, and then we add on, well, probability that we pick a white, that will be 5 over y plus 5, and then we're going to multiply this by, so we've picked a white, now we pick a black, so that will be y lots of y over plus 4. And this is equal to 6 over 11. Okay? So now we need to find out what, we need to show that 3y squared minus 28y plus 60 equals 0. So if we tidy this up, well, we can write everything over a common denominator. The common denominator here will of course be y plus 5 lots of y plus 4, and here on the top we've got 5y plus another 5y. Common denominator is y plus 5 lots of y plus 4. So here we've got this result equaling 6 over 11. So therefore, if I tidy this up even further, we're going to have here y plus 5 lots of y plus 4 on the bottom. Here we're going to have 10y, and this is equal to 6 over 11. So all the hard bits done now. Now we just need to simplify everything. So here we're going to have 11 lots of 10y equaling 6 lots of y plus 5 lots of y plus 4. So let's tidy this up. We're going to have here 110y equals 6 lots of, well, if I expand this out, we get y squared plus 9y plus 20, and if I expand the 20 into the bracket, we've got 6y squared plus 54y plus 120, and this is equal to 110y. And if I take everything over to one side, we get 6y squared minus 56y plus 120 equals 0. And if I divide through by 2, we get 3y squared minus 28y plus 60 equals 0. And that's exactly what we wanted to show. Now for part B, we have to find the probability that Joshua takes 2 black socks. So here, we first of all need to find out what y is, and then use that information to figure out the probability of 2 black socks. So if I solve this equation here, y is equal to, well, I need to use the quadratic formula, so I've got minus b, so I've got minus 28, plus minus b squared, so I've got minus 28 squared, minus 4ac over 2a. So if I square root this, and then tidy all this up, we can work out what this is. So here, well, if you've got the class whiz, you can simply go straight to the equation solver. We have a polynomial of degree 2. We've got 3y squared minus 28y plus 60. So we get y equals 6 and y equals 10 over 3. So y equals 6, or we have 10 over 3. Now this value here, we need to reject, because we need a whole number of socks. So we need a whole number of socks. So therefore, we've got y equals 6 as our only solution. So now we're finding out the probability that we take 2 blocks. So probability that we get 2 blocks. Let's grab our ruler again. Well, here we've got y over y plus 5 multiplied by y minus 1 over y plus 4. So we're going to multiply this by y minus 1 lots of y plus 4. So if I work this out, we're going to have 6. So y equals 6 is only solution. So here I've got 6 over 6 plus 5 multiplied by 6 minus 1 over 6 plus 4. Okay. So if I work this out, I've got 6 over 11 multiplied by 5 over 10, which is 3 over 11. So this is equal to 3 over 11. So this 3 over 11 is my final answer. So we have 3 over 11. Question 23 for part here, we have to write 2 lots of x squared plus 16x plus 35 in the form a lots of x plus b all squared plus c, where a, b and c are integers. Well, here we need to complete the square. So here we have 2x squared plus 16x plus 35. And if I take out a 2 as a common factor from these two terms here, we've got 2 lots of x squared plus 8x. And then we still have the plus 35. Now we complete the square of this big bracket. So if I do that, we've got 2 lots of, well, half of the 8 is 4, so I've got x plus 4 all squared. Then I subtract off the square of 4, which is 16, close big bracket. Then I add on 35. So if I expand the 2 into this big bracket, I've got 2 lots of x plus 4 all squared. Then 2 times minus 16, that's minus 32. And I've still got the plus 35. So we've got 2 lots of x plus 4 all squared minus 32 plus 35, that's plus 3. So therefore, we end up with 2 lots of x plus 4 all squared plus 3. Now for part B, hence or otherwise, we have to write down the coordinates of the turning point of the graph of y equals 2x squared plus 16x plus 35. Well, if we know that y is of the form a lots of x plus b all squared plus c, the turning point from here has coordinates minus b, c. So therefore you can see, if we look at what we have here, the coordinates of the turning point will be minus 4, 3. So we have minus 4, 3 for the turning points of the graph of y equals 2x squared plus 16x plus 35.